Hello and welcome to the next lesson, and topic today is cast rule. So it's the goal. I want you to be able to explain to me what the cast rule is and then use it to help determine the value of the angle theta. All right. So this is going to be new material altogether. Haven't seen this before. So you already have this probably printed out, so it looks a little bit daunting, but once we fill in some of the information, it will make it look not so bad. All right, so terminology. First thing I want to do is start up there in the top corner. I want to talk about terminology that's needed here. So when we're talking about an angle, we need to know what quadrant we're talking about. So we have our quadrants 1, 2, 3, and 4. So they are numbered counterclockwise in terms of the quadrants. The center or the origin is always where the line or terminal arm will be extended from. So when we draw a line in one of the quadrants to make an angle theta, so that's the angle that we're talking about, that is called our terminal arm. All right, so terminal arm, and I know you're yeah, so there's your terminal arm. What we're going to be focusing in on is I'm going to convert the sides of the triangle, how we traditionally label them, because we're creating a right angle triangle up here. All right. Now, traditionally, we would mark this as the opposite side. This would be hypotenuse, and that's the adjacent side. What we're doing is we're just going to change the terminology just a little bit, because if we plot this terminal arm on the XY axes, we find out that the adjacent length is actually the value of x. The opposite length is actually the value of y. All right, so that means our terminal arm, and I'm going to put that in here, terminal arm is always a positive length. And should spell positive, right? A positive length. All right. All right, so that all ties together where we're heading today. So, oops. There we go. So, recall, I just want to talk about special triangles for 1 second because they're going to come back into play here once we go through this lesson. So, for the 45, again, 1, 1, root 2. And for the 30 degree, I know I drew this one backwards to how I have been drawing them. But 1, and that's root 2, and that's root 3. That's my 60. Okay, so here we go with cast rule. So I'm focusing on this chart that I have down at the bottom. All right. So with the chart, you're looking at our 3 primary trig ratios: sine theta, cos theta, tan theta. All right, and we know that sine theta is equal to opposite over hypotenuse, cos is adjacent over hypotenuse, tan opposite over adjacent. What I'm going to do is I'm going to look at the terminal arm in all 4 quadrants of the XY axes. So the first one, we are looking at quadrant 1 for theta. The next one, we're going to look at quadrant 2, and this now becomes my theta. Quadrant 3, and then quadrant 4. So I'm just putting that terminal arm in the different quadrants, and we're going to talk about the angles, the ratios themselves. So first quadrant, start there. To make the right angle triangle, starting at the origin, I would go to the right, and then I would go up. Well, if I go to the right and I go up, that means that my x value is positive. So x is positive, and y is positive, because it's in the positive directions. So the terminology then, opposite over hypotenuse, if you look above, up here, okay, opposite is your y value, adjacent is your x value, and then the hypotenuse is your terminal arm. So the terminal arm is, and I'm going to leave it as h since it's something you're comfortable with, sine is opposite over hypotenuse. So it'll be the ratio of opposite is y over hypotenuse, h. Now the y value, I said, is positive. The terminal arm is always positive. So if you have a fraction where y is positive divided by positive, the resulting fraction will be positive. So what I'm trying to say is that in quadrant 1, because opposite divided by hypotenuse, the opposite length, the y value will always be positive, terminal arm is always positive, then the decimal or the fraction that we'll get for an angle between 0 and 90 will always be positive. All right. Cos. Cos, the adjacent side is x, and the hypotenuse is still h. In that quadrant, x is positive, terminal arm is positive. Positive divided by a positive will be a positive. For tan, opposite is my y value. Adjacent is my x value. Both of them will be positives in that quadrant. Positive divided by positive is a positive. In quadrant 2, so making my triangle from the origin, this will be what my triangle looks like. My x value will be negative because I'm going down the negative x-axis. However, my y value will still be positive. The hypotenuse always remains a positive. So sine is my opposite, which is my y value. So positive y over the hypotenuse, positive h. All right, it always remains that. Even though the angle, the way we're drawing it, the angle, and we're going to talk about this a little bit later on, even though the angle is outside the triangle, when we use the Cartesian plane, it's still opposite divided by hypotenuse to get that angle. Positive divided by positive will be a positive. As I work my way through, cos, my adjacent, which I said was x, so it'll be negative x over hypotenuse. Here's the first time we have a change. Negative divided by positive is negative. And tan is opposite, so positive y, over my adjacent, which is negative x. So again, positive divided by negative will be negative. Okay, so I'm just looking at what would the fraction turn out to be in terms of the sign. I don't care about the value at this point in time. Quadrant 3, I have to go along the negative x-axis, and now I have to go down the negative y, but the hypotenuse, the terminal arm, always remains a positive. So for sine, opposite over hypotenuse, so I'd have negative y over the hypotenuse. Negative divided by positive will be negative. For cos, the adjacent side, negative x over the hypotenuse. This one will be negative. For tan, tan then will be opposite over adjacent, so negative y over negative x. Negative divided by negative is a positive value. All right. Finally, when we look at it in the fourth quadrant, I will need a positive x value, but I need a negative y value to get to the end of the terminal arm. Hypotenuse still positive. So we would have negative y over positive hypotenuse. So sine would result in a negative value. In quadrant 4 with the cosine, you would have positive x over positive h. Resulting value is positive. And finally, negative y over positive x is a negative value. So from this chart, there is a pattern. And this is where cast comes from. If we look down the first column here, so I'm looking at the first quadrant. My results here, everything's positive. So I'm going to say all trig ratios are positive. So that's what A stands for. If we look at the next category, or quadrant number 2, the only one that's positive is the sine. In the next one, the only one that's positive is the t for tan. And the next one, the only one that's positive is cosine. So when we rearrange it, and I'll put this on the next slide, so for you it's just below, or you have the space to finish this off. The summary here then, so for a cast rule, what we end up with, and you're going to be drawing this over and over again, we have our quadrants, 1, 2, 3, 4. And 4. Putting in the values, I said all values are positive in quadrant 1. Sine is positive in quadrant 2. tan is positive in 3, cosine is positive in 4. What mathematicians, to make this an easy thing to remember, is that we start in quadrant 4 and we read in this direction, and that's where cast come from. Okay? So the letters of cast indicate in which quadrant in each quadrant. So letters of cast indicate in which quadrant which trig function will be positive. All right, so as we go around, we would start on the x-axis, so this would be 0 degrees. As we move counterclockwise, this is 90 degrees. If we keep going around, we are now at 180. Continue around. We're now at 270. And when we return to where we began, it's 360. It's like a circle, so we've gone all the way around. All right, so we can indicate, or I know immediately, what quadrant the trig values will be positive or not negative. So you can check this. So the examples. So again, A stands for all, S stands for sine, T is for tangent, and C is for cosine. So what does this tell us? If I had sine of 300 degrees, 300 degrees puts me into quadrant 4, because down here I have 270. All right, so here's 360. So 300 is in between those two. So I'm in here somewhere. I'm in quadrant 4. I know that in quadrant 4, only the cosine function is positive. So that means that whatever I punch on the calculator, it will turn out to be a negative result. And now you can check this with your calculator. It actually works out to be, when you punch it in, negative 0.866. All right? I knew it was going to be negative before I even punched in the calculator. If I had tan of 200 degrees, so 200 is between 180 and 270, so it's going to be here. Tangent is positive in quadrant 3, so I know that whatever I punch into the calculator will result in a positive value. So when I do tan of 200, I get positive 0.36. That's all the cast rule is telling us. Okay? This is the whole point of cast rule right here. The letters of cast just tell you in which quadrant the trig functions are positive. Okay? And you can play with this all you want. You are going to find that it follows that rule. All right? So one last example then here. Cos of, let's say 120. 120 degrees falls between 90 and 180. Only sine is positive in that quadrant, so cosine must be negative. You can check with your calculator, take the cos of 120, and you get negative 0.5. So it is a perfect indicator of exactly what quadrant it's going to be in. All right, so in the later part of this video, we're going to start looking at using this function and how cast rule is used, and then we're going to talk about solving equations in the next lesson.